Alright guys, I'm glad you're watching this because that means that you care. I'm just kidding. I'm kidding. Alright, so let's go ahead and look at the study guide. I know it's a little awkward, so I'm going to try to hold it right here for you guys. I want you to look at number 1. It says calculate the GCF of 48 and 96. So I'm going to set up my problem. That pencil doesn't work. Number 1, 48 and 96. I like the latter method, to be honest, because I feel like it works 99% of the time. So I'm going to use that, alright? So let's look. I'm going to start with a prime number. Now, please remember, this area is RSVP for prime numbers. So are you going to tell me 4? Are you going to tell me 8? No. So you're going to put prime numbers right in that spot. So I can start at 2, but I can also start at 3. So I'm going to put a 3 here. 3 goes into 48, 6 times. 3 goes into 96, 32 times. Now, I'm going to draw another rung on my ladder, and I'm going to add another prime number. Now, 3 doesn't work, so I'm going to put a 2. 2 is prime. It can go into 16 8 times, and it can go into 32 16 times. Alright? Good so far? If you guys want to try to attempt it, you can always pause this video. Alright, I'm going to draw another rung on my ladder. I'm going to put another 2. So this is prime, right? It can go into 8 times, or 8 4 times, and it can go into 16 8 times. Do I stop here? No, because these numbers are not prime, and I can reduce them further, right? So I'm going to put another 2. 2 goes into 4, 2 times. 2 goes into 8, 4 times. Alright, do I stop here because I've hit a prime number? No. I know you've hit a prime number, but if you can reduce further, keep going. Because look, 2, I'm going to add this 2 as a prime. 2 can go into 2 once. 2 can go into 4 twice. See that? Now I've hit 1 and 2. I can stop because they're prime, alright? So, in order to find the GCF, you see this column? This is RSVP for GCF, greatest common factor. So, what I need to do for these is I need to multiply all these together. So, let's start. 3 times 2 is 6, times 2 is 12, times 2 is 24, times 2 is 48. So these numbers multiplied together give me my GCF, which is 48. Hope you guys can see that. Alright, moving on to number 2. Let me scoot that over. Number 2 says, what is the LCM of 6 and 11? Now, LCM stands for least common multiple. So you're going to be multiplying. Now, there's a trick. If you guys forgot the trick, I will show you the trick. But if you don't, remember, let me show you with the ladder. Alright, so I want to find a prime number that goes into 6 and 11. Now that's an issue because 11 is prime. And that's going to deal with part of our trick, okay? So I'm going to pick 3. Actually, I'm going to pick 2. 2 can go into 6 3 times. 2 can't go into 11, so I got to bring him down, alright? Now I can reduce this further because 3 is prime, right? So 3 can go into 3 1 time, and 3 can't go into 11, so I got to bring them down. Now I want to find the LCM, so remember ladder method. You're going to circle all the numbers on the outside, and it kind of looks like an L. And that should help you remember how to find LCM. Now, 2 times 3 is 6. Times 1 is still 6. Times 11 will give me my LCM. Do you guys notice that 6 times 11 is what we started with? Yep. So, if you know that one of your numbers is prime, you can just go ahead for an LCM problem only. So, if one number is prime and you're doing an LCM problem, you can go ahead and multiply 6 and 11, or do that prime times that number that is not prime. All right? So, my LCM for number 2 is 66. Alright, moving on. Let me adjust my camera. There we go. Number 3. Let's read number 3. So, number 3 says, calculate the GCF of 14, 42, and 84. Now, if I'm going too fast, you guys can pause it and practice these on your own, okay? So remember, your test is on Friday. All right. Whoa, guys, I cannot draw a straight line. Save my life. There we go. All right, so I want to find, remember this is RSVP for prime numbers. So give me a prime number that goes in all of those as large as you can get it. So 2 can work. I don't think 3 would work. Well, yeah, 3 wouldn't work. So 5 wouldn't work, but 7 does. So 7 is prime, it goes into 14 twice. 7 goes into 42 6 times, and 7 goes into 84 12 times. Now, I'm gonna do another rung on my ladder because I can simplify these further. So I'm gonna use 2. My smallest number is 2, and 2 actually is prime. So 2 goes into 2 once, 2 goes into 6 3 times, and 2 goes into 12. Wow, guys, I'm having a brain fart. All right, so I have 2 prime numbers. I'm gonna stop right here, all right? So I wanna circle my side column, because remember these 2 numbers, when you multiply them, it could be 5 numbers. As long as they're on your left column, they give you your GCF. So 7 times 2 is 14. That's my greatest common factor of all these numbers, all right? Now, number 4, sorry guys, you can hear my puppy. She's excited. All right, number 4, let's read that together. The greatest common factor of 2 prime numbers is 1. Remember, a prime number is the number times 1. So for example, 5 and 3. You can only get 5 by doing 1 times 5, right? That's a multiplication sign, please remember that. And 3, you can only get it by doing 1 times 3. So their greatest common factor is 1. Cool, huh? All right, moving on. Number 5. Sorry. All right, number 5. Now, it says, list the first 5 multiples of 6. So remember, multiples, like LCM, least common multiple, I'm going to be multiplying this. So 6, 12, keep going. Let me list them right here. 6, can you see that? Come on, gang. There we go. 6, keep going. 12, 18, 24, 30, 36, and so on. So remember, least common multiple. Multiples mean you're literally just multiplying. 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5, 6 times 6. They're multiples of that number. Please don't mix those two on your test. All right, moving on. Let's read number 6. If I can find it. Here it is. All right. During its grand opening weekend, a restaurant gave every second customer, remember, circle your important numbers, a free soda, every 8th customer a free appetizer, and every 12th customer a free piece of pie. I wouldn't mind being the 12th. Which customer was the first to receive all 3 free items? Now, what kind of problem is this? I'm hoping you said LCM, because if you did, you are correct. So, I'm going to list all these numbers. So you guys see how I circled? Can you all see that? Let me zoom in. Oh, wrong one. Alright, so. Come on, focus. Y'all, I am not tech savvy. Oh well, let's do this. Alright, perfect. Now, I'm going to circle 2nd, 8th, and 12th. Now, those are my numbers, right? So, I'm going to list them here for my LCM. So, 2, you guys, there are a few ways you can do this. I'm just going to show you how to do this, the ladder method. First, let me see, for Times 2 is 8. Yeah, okay. So I'm going to show you the ladder method first, and then I'm going to show you just listing out if you guys wanted to do that as well, okay? So I'm going to list out 2, 8, and 12, right? All right, I got to get a prime number that goes into all three of those, and that can only be 2, right? So 2 goes into 2 once, 2 goes into 8 4 times, and 2 can go into 12 6 times. Now, I don't have 2 consecutive prime numbers like I did on number 3, so I have to keep going, right? Because 4 and 6 have a prime that goes into both of those. So, I told you I'm not good at straight lines. All right, so can 2 go into these? Yes. So 2 goes into 1, it can't, so I'm gonna just bring that down, all right? So 2 can go into 2 twice, 2 can go to 6 3 times. Now, I have 2 prime numbers, so I can stop right there, okay? So this is an LCM. Remember, please label, because I don't want you to get confused. So LCM, I'm gonna make my L. So 2 times 2 is 4, because we're gonna multiply these together. 4 times 1 is 1, 4 times 2 is 8, 8 times 3 gives me 24. So the 24th customer gets all 3. They get the pie, they get the free soda, and they get the free, what was it, appetizer. So again, if you didn't know how to do LCM ladder method, you can list them out. So let me show you. 2, 4, 6, 8, 12, 14, 16, 18, 20, 22, and 24. Those are my multiples. Remember, least common multiple. See that problem? Those are my multiples of 2. Now you can list out 8. If you want, you can pause and do them on your own. But if you don't want to, that is more than fine, all right? So I'm going to stop right there. And then 12, because let's see. Yeah. So let me show you. They happen to get 24 as their common multiple. That's the first number that they hit. All right. So the 24th customer gets all 3, free appetizer, pie, and drink. All right. So moving on. Number 7. There we go. All right. Number 7 reads, Miss Sparrow is making baskets of muffins. She has 36 lemon muffins and 54 blueberry muffins. How many baskets can Miss Sparrow make with each type of muffin distributed evenly? What is in each basket? So, let's look. Number 7. What kind of problem is number 7? You tell me. Alright, so if you said GCF, you are correct. So, I'm going to list 36 lemon and 54 blueberry. So, what kind of prime number can go into 36 and 54? 3? Yeah, you're right. Good job. So 3 goes into 36 12 times. And 3 can go into 54 how many times? 18. Good. Now, y'all, I am just dead sad. Alright, let's do it one more time. Give me another prime number that can go into 12 and 18. You can do 2. Or you can do 3. I'm going to do 3. 3 can go into 12. Wow, guys. Brain fart. 4. 3 can go into 18 6 times. Do I stop here? Nope, because I've got another prime that can go into both of them. And that is 2. 2 can go into 4 twice. 2 can go into 6 3 times. Now I can stop because 2 and 3 are both prime, right? Alright, so it's a GCF. I'm going to circle only my left column. Remember GCF, you just do your left. So multiply 3 times 3. I'm sorry, guys. That's 9 times 2 is 18. So my GCF is 18. So she's got 18 baskets, right? Wonderful. Now let's move on to number 8. Now, let's read number 8. Number 8 says the number 150 can be expressed as the sum of 150. Now, use the distributive property to rewrite that sum as a multiple of the sum whose addends, I'll show you what that means later, have no common factors. Now, let me show you. So I'm given 150 as my numbers. So I'm going to draw my ladder. I want to pull out my greatest common factor, because you guys remember we did the distributive factor. Well, we found the GCF using distributive factor. So I've got 150. Let's start with a prime number that can go into both 150. So I'm going to start at 2. Probably could start higher. So 2 goes in 150 times, and 2 goes into 50 25 times. Now, I'm going to draw another rung because I can simplify that. I'm going to use 5 as my prime this time because 5 can go into 50 and 25, and 5 is prime. So 5 can go into 50 10 times, and 5 can go into 25 5 times. Am I done? No, I know this is prime, but look, we can simplify a little bit more, right? So this is prime, so I'm going to put it here because look, that can go into 10 as well. So 5 can go into 10 twice, and 5 can go into 5 once. Now, I've hit 2 and 1, that is prime, so is that, you're good to go, you can stop. Now, this is a GCF, right? We want to look for GCF. So 2, we want to multiply all these. 2 times 5 is 10, times 5 is 50. So 50 is my what? GCF. Now I'm not done because I want to set this up in that type of equation with the GCF on the outside of the parentheses. So my GCF goes here, and remember I had my parentheses, and these two numbers that were stuck at the end, that's what you guys transcribe as your addends. So remember, we're going to put 2 plus 1. If you want to check yourself, you can do 50 times 2, which gives you 100. That's what distributive means. And I'm going to distribute the 50 to the 1. I get 50. I checked myself. Am I correct? 100 plus 50. Is that what we started with? Yep. So I did that correct. So my answer would be right there. Good? Alright, if you're good to go, we can move on to number 9. Let me adjust this. Alright. Let it focus. There we go. Number 9. So, number 9 reads, you guys can see this. So I want to factor 48 and 80 using GCF, greatest common factor, and the distributive property. So let's do this again. So I'm going to do 48 and 80. Draw my little ladder. Now I want a number that can go into both, right? So let's put a 2. Let's start with 2. 2 can go into 48 how many times? 24. And 2 can go in 80, 40 times. Good so far? Alright, let's keep going. Now, I'm going to use 2 again, only because it's pretty simple. So 2 can go into 24 12 times, and 2 can go into 40 20 times. Now, I can't stop. I still got to keep going. I'm going to use 2 again, because 3 doesn't work.